So starting with LLM as a judge. The idea behind LLM as a judge is you, as the name implies, you're using another LLM to judge some aspect of your application. So typically the way that this will work is you'll have your application run, whether in a development or production environment. You can kind of do this in a testing environment or do this in a live environment. And so you can go through, have your application run, gather information about that particular run of your application, and then go form a new template from that information, and then ship that off to a separate LLM to have that separate LLM make a decision about some aspect of that. So this is really powerful because it's very broad in its capability, but it is using another LLM to make that decision. So at the same time, you are introducing some variability in there too. So just to walk through the example here, it is showing the a hallucination eval for an LLM system. So you can see the app is running here, and we're getting in a query from a user that is then retrieving some context information to help answer that question. It's feeding that whole thing into the app or into our LLM, which is then coming back with some sort of response. And so that's a typical kind of RAG pipeline that you might see. And then with LLM as a judge, what you're doing is you're grabbing the query, the context, and the response there, and you're taking those and forming a new template in this case based on that information. And it's usually asking something like, okay, is the response fully grounded in the context that was retrieved? Is there anything in the response that's not supported by the context, for example? And so you create a prompt with that, and then you actually ship that over to another LLM, and then have that LLM classify whether or not there's anything in that response that is not supported by the context. So this is an example of kind of hallucination detection eval, and so it's kind of what you could use for the template there. And I'm actually going to go slightly off script for a second here, and I'll show you guys really quick what a template of this actually looks like as we go through too. We're going to see this in a second a little bit later on, but just to kind of really hammer this home. So for this hallucination template, for example, you might just have a template that looks something like this. So you can see there's some existing instructions that are included, and then you can see there's some details about how to respond. And then you see we're adding in the question, the reference text, and then the answer. And then you see it's asking, is the answer factual or hallucinated in this case? And you could really define this template to be whatever you want, which is where these get very flexible. You can use a lot of different kinds of evaluation for these. So there's a couple considerations to make. Usually at this point in the presentation, people are wondering, okay, if I'm just going to use another LLM to do this, is that really going to work? Are we just going to add in additional hallucination information that's going to come up there? How does it actually work? And the answer is yes, you are adding a variable component. So it's important to remember that LLM as a judge is never going to be 100% correct. There will always be some variability in there. You can do things like tweak the template to align the judge to human data as much as possible. The other thing to remember is that if you use some of the best models, you're typically going to have them align pretty closely with human judgment. There's a question in the chat, which is what's the best size model for LLM as a judge to minimize the need for judging the judge itself? There is a great paper that goes into this in detail that is called I think it's Who Judges the Judges is the name of it, or something along those lines. And it goes into a bunch of detail on this. But one of the takeaways from that is that as you start getting into kind of the GPT-4 level models, then you were seeing much more alignment with human results. And so now that we're in this world of GPT-4o, GPT 4.1, Claude 3.7, some of these like marquee state-of-the-art models, Llama 4, whatever it might be, all of those models are going to align pretty closely with human judgment. And so as we've seen that, then, and when I say pretty closely, I mean kind of 95, 98+% alignment with human judges. And so as we've gotten to that point, now the question becomes, okay, how much can we reduce these? How small can we go as we go through it? Anecdotally, from my own experience, using what I call the SLMs, or small language models, something like a GPT-4o Mini, Claude Haiku, some of these smaller models, even a Llama, like an 8 billion parameter Llama model, for example, has decent alignment with human judgment. The reality, though, is it's different depending on the template and the task that you're asking it to do. So there's no one size fits all of saying, hey, you can use an 8 billion parameter model and you'll be fine. It does depend on the task itself. And so oftentimes we'll actually benchmark templates or models to get a sense of how those models perform on each different task. And then that brings us to number 3, which is tuning your LLM judge prompt or model can help close the gap. So that is something that you can do too, is you can either tweak the prompt of your LLM judge, or you can actually use a fine-tuned model itself to try to improve that performance. So there's a couple questions here. One is around, are there domain-specific LLM judges? And that is something that does exist. There are domain-specific LLM judges. Actually, a project I worked on earlier this year, we fine-tuned an LLM judge where we took a 1.5 billion parameter Quen model, and we're able to get it to perform about on level with a GPT-4o, or GPT-4, excuse me, model, in terms of identifying that hallucination prompt that you just saw earlier. and kind of identifying those labels. So you are able to kind of bring things up with training. And so you can fine tune. We at Arise, we have a fine tune model that we use. There are actually a bunch of other startups and companies that also fine tune eval models for just this reason, because you are adding additional cost if you're going to use another LLM for this. So using those small models can help. A couple other quick questions that are in here that I want to touch on. One is, can LLM-as-a-Judge be used for agent function calling architectures? Yes, it definitely can. And that's actually the example we'll walk through in a little bit. LLM-as-a-Judge can kind of be used for almost anything you want it to. It's just a question of whether it's going to be accurate for it. Tool calling is a great tool calling accuracy is actually a great task for LLM-as-a-Judge, because you can provide it the options and you can kind of provide a context, and it works pretty well in that case. And there's another question, which is, do reasoning and thinking models help? From what I've seen in my own testing, and I'll preface this by saying this is just from my own experience, the reasoning and thinking models do a good job with this. However, it's almost overkill in some cases, because typically if you're doing LLM as a judge, you want to scope down the task that you're asking your LLM to do. If you look in this case back here, we're not asking just, is the response good or anything like that. We're asking very specifically, does the response include anything that was not in the content? And the more you scope down the question, the more accurate you're going to be. Thinking models are kind of overkill if you're scoping it down in that way. You could use them for broader kind of things and to kind of evaluate the whole run through of an agent, for example. And that would actually work pretty well. I think the consideration that comes into play there is the cost. So you are adding a lot more cost if you're using some of those thinking or reasoning models. Although I should say maybe R2 could be a good case there, where it's actually not necessarily as expensive, but you could use those thinking models as well too. It's a little bit of, if you use more firepower, you're going to have a more accurate approach. But there's nothing specifically about the thinking or reasoning models architecture that is so much better at LLM as a judge in particular. It's just that they're usually more accurate across the board. There's a fun experiment that we're trying to do, though, of figuring out if we can use the actual thinking token outputs basically to tune judges. So maybe more on that if you keep following along. Cool. And then my last bullet here to just touch on, generally, it is always better to have your LLM judges do discrete classification labels as opposed to just ranges of scores. So if you say to your judge, classify this as hallucinated or factual or incorrect or correct, or even put this into buckets of 1, 2, 3, 4, 5, and 1 means this, 2 means this, 3 means this, 4 means this, 5 means this, that will also work as well too. If you tell an LLM to score something out of 100 and don't really give it specific ideas of what those different scores mean, then it's not going to be very accurate. So I think the issues that you run into is that it has no recollection of previous judgments that it made. And so each judgment is just going to be kind of random in that range. And there's no benchmarking that it can do. And you can't tie a 79 to something versus like an 82. It has no concept of what those different things would be. So generally you want to use discrete labels as opposed to just purely undefined scores. You can then calculate scores based on those labels. You can say, hey, an incorrect is 1 or a 0 and a correct is 1. So you can still get a numeric representation. But if you start with a classification label and then do the score element, that's going to usually be a better approach.